A water tank is 12 feet high, 5 feet long, and 9 feet wide. A solid metal box, which is 7 feet high, 4 feet long, and 8 feet wide, is sitting at the bottom of the tank. The tank is filled with water. What is the volume of the water in the tank? So let's think about this. We have a water tank. It's 12 feet high. Try to draw this as good as I can. So it's 12 feet high. It's 5 feet long. So this looks like that's about 5 feet. And it's 9 feet wide. So this is my best rendition of what the tank looks like. So the tank might look something like this. That is my water tank. Let me draw it. Draw the whole thing. So there's my water tank. And I'm going to make it transparent so that we can see what's going on inside of the tank. So here we go. There's like a helicopter outside or something. I don't know if y'all hear that. But let's see. So there is my water tank. 12 feet high. 12 feet high, 5 feet long, and 9 feet wide. 9 foot wide. And then they say there's a solid metal box, which is 7 feet high, 4 feet long, and 8 feet wide, sitting at the bottom. Sitting at the bottom. So let's see if I can draw that. So let's say it's 4 feet wide, 4 feet, or I guess we could say 4 feet long, 7 feet high. So let's see, 4 feet might look something like this. It's 7 feet high, which might look something like that. 7 feet high. Obviously, I'm not drawing it perfectly to scale. 7 feet high and 8 feet wide. So it might look something like this as it's sitting in this tank. So this is that metal box. And and they say it's a solid metal box. It's not like any water can fit in here. So let me make it as a solid metal box. So this is a solid metal box. And then I'm going to fill the whole thing. I'm going to fill the whole thing with water. I'm going to pour water into this thing. And the water is going to start filling up. And it's going to fill up all the volume of the tank except where the metal box is. It's not going to be able to fill in that volume because the metal box is solid. So it's going to fill up. We're going to slowly fill this thing up around the metal box. So what's the volume that it's going to fill up? Well, it's going to fill up the volume of the tank minus the volume of the metal box. It couldn't fill in the metal box volume. So let's figure out what that is. The volume of the tank is going to be 9 foot by 5 foot times 12 feet. That's the volume of the tank. Tank volume. Tank volume. And from that, we want to subtract the metal box volume. So minus 4 foot by 8 feet. By 8 feet, 8 feet by 7 feet, by 7 feet, by 7 feet. This is 4 feet wide. It is 8 feet. What do they? Oh, they say it's 7 feet high. 7 feet high. It's 4 feet long and it's 8 feet wide. 8 feet wide. So this right over here is the volume. This is the, I guess we could call it the metal box volume. The box volume. And so what's in between, or when you take the tank volume, subtract out the box volume, that's how much the water can actually fill in. So I only do the water partially filled, but once it's already filled in, the water's going to go all the way to the top here, and it will fill in everything except for where that blue box is. So let's figure out what this value is. So 5 times 12 is 60. 60 times 9 is 540. And then in blue here, let's see, 4 times 8 is 32. 32 times 7 is 210 plus 14, which is 224. So it's minus 224. Minus 224. Did I do that right? I don't want to make a careless mistake. So 32 times 7. 2 times 7 is 14. 3, which is really a 30 here. 30 times 7 is 210. Plus another 10 is 220. So 224. So this is going to be equal to, let's see, 500 minus 200 is 300. 300, and then 40 minus 24 is 16. 316. And our units are in cubic feet. So the volume of the water in the tank, 316 cubic feet.